Next problem up. Let's begin by reading that question sentence always. Again, it's never an option. Always start with the question sentence. What was the plane's speed on the second leg? All right, two questions, everybody. Two questions. One, what does speed translate to in terms of the topic of discussion for this problem? Speed translates to rate. Exactly. So let me highlight that. We want rate. We want rate. Now, on top of that, everybody, on top of that, specifically, the rate for what are we looking for? Is it the entire flight? Is it the first part, the second part? What is this rate specifically tied to? Yes, second leg. It's right there in the sentence. It's right there. So we are specifically looking for the rate for the second leg. Specifically, we're looking for the rate for the second leg. Now that we know that, now that we have that envisioned, what we're going to do now is try, key point, key word there is try. We're going to try to set up our formula in that context. So I'm going to say distance for the second leg. And I'm just going to use this right there. The distance for the second leg equals the rate for the second leg multiplied by the time for the second leg. We have got to be consistent. Now let's see, let's see if these pieces of information can be found in the problem. If not, if let's say, given that we're looking for rates, I'm just going to mark that right now. Let's say we do find the distance, but we don't have the time. Well, guess what? We are going to have to find a way to find the time. Because once we have the time, then we can calculate for the rate. So I hope you see it that way. We have the distance and the time that we have to find. Then we plug them in and solve. Let's see what we have. A plane flies 150 miles at 300 miles an hour. Then 250 miles more. Okay, that's all they say about the second leg. 250 miles more. So that's my distance. I'm going to plug that in here. 250 miles. And then we have the rate that we're looking for. Everybody, do you see that we are not given the time for the second leg? Instead, we are given the time for the whole flight. Do we see that? Do we realize that? Do we notice that? Good. So now that we notice that, let's figure out a way to get that time. What other time do I have? I have the whole trip. I also have the first leg, 150 miles at 300 miles an hour. When I look at that, I say, okay, I have distance, I have rate, I can find time. I can absolutely find time. So let me do that. Let me highlight that in blue. Let me set up a little working area for myself here in blue on the side. And let's find, for that first leg, let's find the time. So we have the distance being 150 miles. The rate is 300 miles per hour. And we multiply that by time. So clearly what we have to do is divide both sides by 300 to get the time by itself. Everyone, what do we notice about the relationship 150 divided by 300? What are we going to get exactly when we do that division? And even, you don't have to be a pro at long division to know this. What I notice is that 150 is half of 300. 150 is exactly half of 300. Knowing that relationship, I can write the time as half. Half of 1, 0.5. And there we are. So the time is half of an hour for the first leg. And we know that the total time is 1.5 hours. So my party people, you tell me. You tell me here. What is the missing time that we're going to be adding in? Half an hour plus what gives us an hour and a half? Exactly 1 hour. Exactly. So we're gonna plug that in right here. 1 hour for that second leg. And now we're good. because anything times 1 is just going to be itself. It's just going to be itself. So by de facto, the rate is going to be 250 miles per hour. And that's going to drive in the correct answer as B. All right, next question. So, as always, read the question sentence first. And it reads, how many cookies remain? Okay, sounds good. How many cookies remain? Perfect. So I'm going to highlight that. My party people, typically when we see the word remain, typically what operation are we going to be conducting? Yeah, always going to be a hint for subtraction. Always going to be a hint for subtraction. So we want to know how many remain. And when we just take a look at the story here, let's just kind of take note of everything that's going on. I see here that it says, a bakery bakes 7 trays of 9 cookies each. Then 11 cookies are eaten. So let's first just pause real quick and think about it. If we have 7 trays of 9 cookies each, so 9 cookies per tray, how are we going to get the total number of cookies in all 7 of the trays? Yeah, that's going to be multiplication all the way. That's going to be multiplication. So let me just highlight that right there to say that I will be multiplying 7 multiplied by 9. We already know that that is going to be 63, so we'll just write that down. But we have 63 cookies in those 7 trays. Now, when it says, then 11 cookies are eaten, when we're trying to figure out how many cookies are left, what operation is that going to tell us to do? Yeah, that's going to tell us to subtract 11. So let me just circle the 11 that are eaten, and I'm just going to write minus 11. I'm not going to actually do the math yet, because I just want to make sure that I have the optimal path when I'm getting this done. So with that said, next up it says, later, the baker makes 2 more trays of 8 cookies each and sets aside 5 for samples. Okay, let's read into that. Reading into that, it says again, 2 more trays, each with 8 cookies. We're going to be doing 2 multiplied by 8. Absolutely. Let me highlight that in green. There are 2 more trays of 8 cookies each. That'll be 2 multiplied by 8, which is 16. And then it says we set aside 5 for samples. Everybody, what does that mean? What does that entail? Setting aside 5 for samples. Yeah, those cookies aren't there anymore. They're not available for us to consume. They are set aside for samples, not in this batch, not in what we're discussing here. So we'll subtract 5 from that 16. So to find the grand total here, we are going to have to go ahead and figure out how many cookies we actually have from that first batch, how many cookies from that second batch, and then we'll add them together. That's one way of doing it. Another way that a lot of people like to do is perform the additions first, 63 and 16, which is 79, and then this will be 16. So then you have 79 minus 16, and that'll give us 63. So we can do it a couple of different ways, but here the way I'll do it is, again, 63 minus 11, that'll give us 52. And then we have 16 minus 5, which gives us 11. So we add those cookies up from either batch, giving us, again, 63 cookies remaining from this situation. So there we are, my party people. Hopefully we're feeling good, and hopefully you're ready for another one.